Welcome back to Digital Switching Systems virtual class. Today, we will discuss the building blocks of a digital switching systems. Here we are taking an inside-out approach to understanding and developing various concepts associated with a modern digital switching system. The development of this digital switching system model is described in 4 stages. The first stage looks at the very basic kernel of a digital switching system, with the switching matrix, which is called switching fabric. Since not all switching systems use a matrix arrangement for switching, the switching fabric switches lines and the trunks under the control of a central processor and network controller. The second stage of this development introduces the concepts of line and trunk modules. The third stage introduces the notion of interface controllers and distributed processing. The fourth stage presents a high-level design of a digital switching system equipped with service circuits. Stage 1 of conceiving a digital switching system is shown in figure. At this stage, all inputs and outputs to a digital switching system are defined. In this particular case, which is a simple one, only lines and trunks are defined. Clearly, there can be many types of lines and trunks. The line and trunk sides of the digital switching system are shown separately. As mentioned earlier, this is only a convention and does not mean that trunks appear on one side of the network and lines on the other. The central processor controls the network controller, which in turn controls the switching fabric. For the time being, regard the switching fabric as a switched path through the CO. Stage 2 of digital switching system design is shown in figure. The concept of line modules, LMs, and trunk modules, TMs, is introduced here. The line and trunk modules are the building blocks of a modern digital switching system, and conceptually they represent some lines or trunks grouped together on circuit packs, termed line or trunk equipment, and connected to the switching fabric through a controlling interface. Modern digital switching systems use various schemes to terminate lines on the line module. Some digital switching systems allow termination of only one line on one line module, while others allow termination of multiple lines on a single line module. Both schemes have pros and cons. If a line module becomes defective, this may impact a number of lines if the line module carries multiple lines. However, if a piece of line equipment becomes defective, the line can easily be assigned new line equipment if the LM carried multiple pieces of line equipment. Similar schemes are used for trunks on trunk modules. In a modern digital switching system, line and trunk modules are designed to be modular, which in simple terms means that a number of these units can be added on an as-needed basis without re-engineering the system. This allows for easy growth and offers flexibility in offering new services. Stage 3. This stage is depicted in figure shown. The concept of distributed processing in a digital switching system environment is developed here. The task of controlling the switching fabric is usually assigned to a series of network control processors that control a part of the switching fabric and a group of LMs and TMs. The central processor controls the actions of the network control processors. This type of architecture is very flexible and allows the construction of different sizes of central office by increasing the number of network control processors. Naturally, the processing capacity of the network control processors and of the central control processor and network size also play an important role in determining the ultimate size of a central office. This type of architecture is used by many commercial digital switching systems. Stage 4 is as shown in figure. Stage 4 of the digital switching system design may appear to be the final stage of a digital switching system model, but it is not. In reality, It is only an initial model of a digital switching system which is needed to develop a more detailed model. This basic model introduces the duplicated scheme now commonly used in modern digital switching systems. Since telephony processing is a non-stop process requiring high reliability, a duplicated scheme for processing units and associated memory units is almost mandatory. This basic conceptual model also shows the attachment of interface controllers and service circuits to the line and trunk modules. The interface controllers allow interfacing and control of LMs and TMs through the network control processors. The purpose of the service circuits is to provide dial tone, ringing, and other associated functions. In a modern digital switching system, each line or trunk module or a group of modules can be attached to service circuits. Thank you. Tomorrow, we will discuss the basics of call processing.